All right, so now we're going to look at solving these trig equations we've been looking at. And the big difference with solving compared to what we looked at in the last unit with proofs is that now I am going to move across the equal sign, and I'm going to isolate whatever trig functions in my problem. So before we start, notice that it's asking me to solve each equation from 0 to 2 pi. Meaning if I think about my unit circle, here's 0, 2 pi is 1 full rotation, right? But notice it's less than 2 pi, so we're not including the 2 pi. So this first unit, we're going to look at solving exact values. And what that means is we're finding things that are on the unit circle. So looking at example 1, identify your trig function. So in this case, I'm solving for cosine theta. And all I'm going to do is some basic algebra to get everything else away from that cosine theta. So first thing I'm going to move is that square root of 2. And divide. So if you notice, square root of 2 over 2 is on my unit circle, right? And that goes with my pi over 4s. So now I just need to identify the quadrants I'm in to get negative cosine. And that would be quadrant 2 and quadrant 3. So I want the pi over 4s that go with quadrant 2 and quadrant 3. And those angle measures would be 3 pi over 4 and 5 pi over 4. So those would be my solutions. Next example, let's look at dealing with tangent. So I need to isolate the tangent theta. So I'm going to add the 2 root 3. And then divide. So in this case, the 2's cancel, and I want to identify the angle that gives me a tangent of positive root 3. So thinking about where tangent's positive, right? Remember, tangent is y divided by x. So that means I need to have a positive y and a positive x, right? Positive divided by positive, or a negative divided by a negative. So quadrant 3. So tangent value of pi over, or a square root of 3, that goes with my pi over 3s. And I need the pi over 3s from quadrant 1, which would just be pi over 3. And the pi over 3 from quadrant 3, which would be 4 pi over 3. Okay. So let's make these a little bit more challenging. 3 is not that much more challenging. I'm going to subtract the 2. And divide. So we can get those quadrantal angles, the ones that are at 90, 180, 270. And cosine of x equaling -1, that occurs in one place, and that is at pi. All right, number 4 is where things start getting tricky. So if I look at the way my equation's set up, this looks like a quadratic equation, just with cosines in it instead of x's. So to kind of show this a little bit easier, we're going to change cosine of x into x, just so we can see the factoring a little bit easier. So instead of cosine squared x, I would have x squared. Instead of -2 cosine x, -2x, and then plus 1. So factoring that, I would get x minus 1, x minus 1. which would just be x minus 1 squared. Now putting the cosine back into that x, and now I can solve, right? I want to get the cosine x by itself, so I got to remove that square by square rooting. Square root of 0 is 0. Don't need the plus or minus in this instance because it's 0, right? Add the 1. So this is where some mistakes will be made. Remember our restriction, right? We're going from 0 to 2 pi, but the 2 pi is not included. Cosine of x equaling 1 happens at 0, and if we went all the way around, 2 pi, right? But because of my restrictions, I'm only going to have 0 as an answer, not the 2 pi. Okay. Now let's look at some that have some double angle stuff involved. So, looking at number 5, I recognize the fact that I have two different trig functions. And when I have two different trig functions, generally we need to do a little bit more work here to figure out how to get them separated. And this sine 2x gives me that opportunity. So I'm going to plug in my double angle formula for sine 2x, and that would give me 2 sine x times cosine x. And looking at what I've got going on in my equation now, I see that I have two different cosine x's. So if I get all of this stuff to one side, I would be able to factor out that cosine x. So I'm going to subtract the cosine x over. And I would get minus cosine x. And now I can factor out a cosine x just like a GCF, right? So I would get cosine x, 2 sine x minus 1. So if you think back to when we solved quadratics, right, back in Algebra 2, and we got our two factors, we would set each piece equal to 0 and then solve. We're going to do the same exact thing here. I have my two factors, right? One has cosine x, the other deals with sine x. But because they're separated into their factors, it makes solving pretty easy from this point. So my first factor, cosine x, set that equal to 0. And cosine of x equals 0 at my pi over 2's. So we would have pi over 2 and 3 pi over 2. Okay, so those are the two answers from the first factor. Now we're going to set the second factor equal to 0. Add the 1, and divide by 2, I would get sine of x equaling 1/2. Sine of x equaling 1/2, first off, it is positive. Positive sign happens in quadrant 1, quadrant 2. And sine of 1/2 deals with my pi over 6's. So I would get pi over 6, right? That'd be the one from quadrant 1. And then 5 pi over 6 for quadrant 2. So my answer to number 5 would be those 4 answers, those 4 radian measures. Okay. Now, number 6, again, I have a double angle, but this time it's cosine. So I need to think about the right formula to use, right? Remember, cosine of 2x has 3 different options. And the way I kind of pick is by looking at what else is involved in the equation. And I see that I have sine. So I'm going to pick the formula that involves sine. And that would be 1 minus 2 sine squared x. Now, just like with quadratics, when you think back to solving quadratics, we always wanted the squared term to be positive. So I'm going to do the same thing here. I'm going to move everything to the right side to make that negative 2 sine squared x positive. So I would subtract the 1 and then add the 2 sine squared x. And I'm going to order it so that the sine squared x is first, just to make it look nicer. So we would have 2 sine squared x plus sine x. The 1's canceled, so all of that equals 0. And they both have sine. So again, I'm going to pull a sine out front like a GCF. I have my 2 factors, so we set each factor equal to 0 and solve. So sine of x equals 0. That happens at 0 and pi and 2 pi, but again, the domain's restricted, so I can't have 2 pi as an answer. So we would just have 0 and pi for that piece. Second factor, subtract the 1 and divide by 2 would give me sine of x equals negative 1/2. Sine is negative in quadrant 3 and 4, and we just saw that sine of 1/2 deals with my pi over 6's. So I need the pi over 6's from quadrant 3 and quadrant 4. And that would be 7 pi over 6 and 11 pi over 6. Okay. Now there is one more problem, and we're actually going to do this one together in class because it's a little bit more challenging, a little bit weirder, and you might be able to see why, and that's because I have that double angle, but if I change it to using the formula, I have 2 times sine times cosine, and I can't really do anything from there. So we have to kind of approach this one a little bit differently, but we'll start with this in class.